Today we will be using all our factoring strategies to be able to factor these polynomials. And so let's take a look at the first set of directions. It says to tell whether each expression is completely factored. If not, factor it. And so basically we've got an expression that has some factoring already done to it. See, they took out a common factor of 3x. So what we want to look at is the stuff inside the parentheses. We want to see, can this be factored further? Well, we look at this 9x squared and a 1. That's a binomial. So this might be a difference of two squares. However, it's not. Even though this is a perfect square and this is a perfect square, we have a plus sign here. And so what that means is this is a sum of squares, not a difference. And that does not factor. And so we would say this is already factored, or factored completely. And you might end up with that type of answer with these problems. So if it wasn't factored completely, we'd factor a little further. Same thing here. Again, we're looking inside the parentheses, and right here I see we have a binomial. Well, is it a difference of squares? We now have a minus sign, so it's a difference. So this tells us that we have a difference, but do we have perfect squares? Let's check. This is a perfect square, yes. But is this a perfect square? No. No, it's not perfect. And what makes it not perfect? It's the odd exponent. And so even though we had k to the third power, if it was k to the second, we could have done it if it was an even exponent, but this was an odd exponent. So no, it does not end up working. So it's already factored. And so we'll say factored completely. Well, let's move on to the next one here. And again, they factored out a 4 for us already. Well, we look, and this one's more promising. We have a difference of squares here, the 1 minus sign, and we have 4p to the fourth. This is a perfect square, which is 2, and p to the fourth is a perfect square, p squared. And then we have the 1, and that is a perfect square as well. 1 is the number, and so this factors to a sum and a difference. So here we have 4 times by 2p squared plus 1, and then we also have a 2p squared minus 1. And you see how the 2p squared and 2p squared make the 4p to the fourth. The 1 and negative 1 make a negative 1. The outside and inside terms are going to end up canceling out because they're opposite in sign. So there is our answer. So that's one thing you should always look for, is when you have a binomial, see if there's common factors and see if it's a difference of squares. And that's what we're going to see on some of these problems. So first thing you're going to want to look for is the common factor. I see 3 as a common factor, but we also have some x's. See, we could take out 3 x's from each of these, because this one has 3 x's. This one has 5, so 3 x's is the highest number of x's we can take out. So once we factor out that common factor, see what's left over. You've got an x squared minus 4. Well, don't think you're done yet, because whenever you have a difference of squares, or binomial, you could end up with a difference of squares, and that's what we have here. See, x squared is a perfect square, 4 is a perfect square, makes 2, and we have the 1 minus sign. So this is going to factor further. It's going to factor to 3x to the third, and an x minus 2, and an x plus 2. Now I know it works out because I know I took out the 3x to the third already. And if I go ahead and multiply out this x minus x times 2 and then negative 2 in the x, they cancel out. That's why we have no middle term here. X and x make x squared. Negative 2 and 2 make negative 4. So I know it ends up working out. So I've checked my work there. Well, same thing here. Again, first thing you want to look for is that common factor. I see that each is an even number, so 2 goes in each. The other thing I see is they all have a p. So let's take out that 2p. And so when I go ahead and do the division, I've got a 4q squared, I've got a positive 4q, and I've got a positive 1. Now let's look at the trinomial. And I see something. I see that this term is a perfect square, and this last term is a perfect square, and they're both positive. So that's a good sign. See, this makes 2q, this makes 1. So if this factors, it's going to be this way. It's going to be a 2q plus 1 and a 2q plus 1. And so let's check. Let's check it. This is checking our answer here. We're going to multiply. I know I took out the 2p, so I know I've done that part right. It's this part right here I need to check. This makes 2q, and this makes 2q. And those two will add together to make 4q. So it does end up working out. That does make sense. And so our answer is 2p times by 2q plus 1. And that quantity is being squared because we have two binomials that are the same. Well, over here again, we're looking for those common factors. See how they both have some m's. They have one m in common. They both have at least one m. And they both have at least one n. So let's see what's left over when we do the division. We might be able to factor further. So here we have n to the fourth, and here we have a minus m to the second. And we do have a difference of squares. See, they're both perfect squares because we have one minus sign and we have even exponents. When you have even exponents, that means you have perfect squares. And so that's what we're looking for, is those even exponents. So when this factors, you see this one will end up factoring to the n to the second, and this one factors just to an m. So it's going to end up factoring like this. M and n, we just bring that down, and then we have n to the second minus m, and then, see, the n to the second plus m is needed because we want to cancel out those outer and inner terms. N squared and n squared make the n to the fourth. Negative m, positive m make a negative m squared. So there is our answer. Well, looking at the next one, here we have common factor again. You see they all can be divided by 3. So we'll take out a 3, and let's see what else. Well, I've got an x squared. So we'll take out a 3x squared from each of these terms. So that goes on the outside of the parenthesis. Let's see what's left over. We've got a 2x squared minus, and then this will just leave us with an x, and here we have a negative 3. So we can't stop there. We need to see if this can factor further. So if this factors, we would have two binomials. And what we can do to start with is put in the 2x and the x to start with. Now I just need to figure out where the 3 and the 1 go, because those are the only options. I've got 1 and 3 and 3 and 1. Well, I'm going to try this one right here. And so I'm going to put the 3 here and the 1 here and see what happens. See, I know the outer and inner terms need to subtract because of this minus sign right here. There's a negative, so outer and inner are subtracting. This makes 3x, this makes 2x, and yes, I can get them to subtract to make 1x. Now, I want a negative, so I'm going to put the negative sign with the 3, positive sign with the 2. And the 2 is the 2x times by the 1. And so there's how it factors. So I know it's right because I've already checked my work in using this method of checking the outside and inside terms. I know 2x and x make 2x squared, that's why I picked them. Negative 3 and 1 make the negative 3, so it works. So 3x squared times by, and then we have the 2x minus 3 and the x plus 1. Well, a couple more problems. Let's check those. And so here we have a 4-term polynomial. We haven't done one of these in a while. Well, when we do these, we're checking to see if we can factor by grouping. So we're going to group the first 2 terms and the last 2 terms because I didn't see any common factors. And so here I see some common factors now. I see p to the third. So I'm going to pull out that p to the third, put it on the outside of a parenthesis. See what's left over. I got p squared plus 3. And so over here, now there's no common factors. So if you don't see anything, always take out a 1. So I'm going to take out a positive 1, so that's why I put it on the outside. I've still got a p squared plus 3. So from this point, now we can go ahead and take out the common factors between these 2 terms. And the common factor is a binomial, p squared plus 3. And over here I have a p squared plus 3. And so that's what I'm going to put on the outside of the parenthesis, p squared plus 3. And I go ahead and see what's left over. See, these are canceling out. So I'm left over with that p to the third plus 1. Once in a while, you'll end up doing this, and you'll get a perfect square. And a perfect square and a minus sign in between. So you might have a difference of squares when you do this in some instances. So always check to see if your binomial can be factored further. But these cannot. They're not perfect squares. Not each of them are perfect squares at least. And there are plus signs between them. Well, let's see if we can do something here. No common factors between these terms. See, 2x squared, 11x, 6. 11 is not even, so we can't factor it. So if this does factor, we're going to try two sets of parentheses. We'll start with the 2x and x. We know that because of the plus sign right here, that means outer and inner are adding together, and they should equal 11x. So we know both signs have to be positive. So we just try our different combinations. You see, we only have a few. We got 2 and 3, we got 3 and 2, we got 1 and 6, and 6 and 1. And we see which end up working. So let's go ahead and try that first set here. We'll try the 2 and the 3, and we check the outside terms and inside terms. Again, we want them to add to make 11x. So let's see if it works. 2x and 6x. Nope, that makes an 8x. So we know that doesn't work, so we try the next. So we just erase what we just did there, and we try the 3 and the 2. So let's put the 3 here and the 2 here this time, and that's even worse. Here we have a 3x and a 4x, and it makes something even smaller. It makes only 7x, so it doesn't work. So we cross it out and try another one. So we go ahead and erase what we've got there and check the next. So we put in the 1 and the 6. Well, this is getting a bigger number here, 1x for the inside, 12x for the outside. Well, that's too big. That makes 13, so that's not right either. So we've only got one more option to try. So we erase what we did there, and we check the next one. So our next one, we're putting a 6 in place of the last term and a 1 in place of the second one. This makes a 6x and a 2x, which only makes 8x. So that doesn't work either. But those are all the different ways we could do it, and none of them ended up working. So what this tells us is we just can't factor it. It's not factorable. So that's what we get to write down. So not factorable. Well, those are some of the types of problems that you'll end up seeing on tonight's homework. Good luck.